All right, so for today, the 17th, here's our plan. We're going to go through the lesson quickly because I have a feeling that we can handle this stuff rather well. I'm going to give back everyone's test. You're going to check every single answer on there because I'm looking for, hopefully, a lot of us to get exemplaries. And then you're going to, some of you need to finish it because some of you weren't done with your homework or whatever else. Then you're going to turn it back in and have the rest of the time to work on your homework. So you could potentially walk out here with no homework to take home with you today. Yes.
I was an idiot. I did not. For some reason, I didn't turn in my test.
Okay, do you still have it with you?
Yes.
Okay, then we'll take care of it. When we all do tests again, that's fine. You can work on it again. So, when we talk about this fancy term called the constant of proportionality, now what's it mean for something to be constant? Andrew? Stays the same. Now, if something is a constant, do I know what it is?
Yes.
Not all the time.
Okay, give me a situation where something is constant, yet I don't know what it is.
Like, if your answer for something, you have to...
How so?
Well, if you, like, 1 plus 1, you find the answer for that, then you'd be like, 2 minus 1, you solve the answer, and your answer could be a constant. No?
I'm trying to follow, but I think you changed what two things you're talking about.
Couldn't your answer be constant, but it's unknown?
Then it's a variable. If it's unknown and I don't know what it is, then it could vary. That makes it a variable.
But the same throughout, like, 7 different problems. If it stays...
So, like 2 times 7. Like 2 times 7. That answer's constant. But saying 28 divided by 2, all because that answer is the same, doesn't make it like the... So I think what you're getting stuck on is saying your answer, like in quotations, is the value you're talking about. You can't say that. You could say like x is the value I'm talking about. Now if x equals 2 times 14, it's a constant. I can solve it. I know what it is. But if x equals z times 5 minus y, I don't know what it is. It's a variable. So things that we know, things that stay the same, those are constants. Now, what do you think it means in the term of constant of proportionality? Jeremiah?
The proportion stays the same.
What do you mean?
Like the amount stays the same, the amount that you have stays the same.
Give me an example.
Like if you have, I don't know, 4 pounds of something, I don't know, and then you do a problem and it stays the same, I guess, I don't know.
Monica?
Like in a proportion, like over there 1 is 20. It's the same thing as 2 is 40. And it's still a constant because if you like simplified it, it would all be equal to.
So, no matter how many I have, the unit rate stays proportional or stays the same. So exactly like Monica's talking about here, if I have 2 bricks that together are 40 centimeters, that tells me that 1 brick would be 20. And I already know that 2 is 40. So then if I keep working onward, how wide would 3 or 4 or 5 bricks be? I want you to fill in this table because my smartboard is apparently having a Monday morning. It's a good morning for some cards.
You know any tricks?
I know one.
What? Me too. I don't know any.
All right. Whitney, how wide or how long, depending on how you look at it, would 3 bricks be? 60. Jeremiah, Han, what about 4 bricks?
Okay. That would be 80 centimeters.
80 centimeters, thank you for the label. Ashley, what about 5 bricks? 100. Now I'm going to go back through the same people. So Whitney, if I look at my ratio of the total length divided by the number of bricks, here we would set up 60 over 3, which comes out to be what? 20. Jeremiah, if I set that up with your situation, what do you get?
20.
And Ashley, with your situation, what do you get? So this 20 is my constant of proportionality because, guys, essentially the constant of proportionality is another way to talk about your unit rate. So your constant of proportionality is really talking about the unit rate. And in this case, it's centimeters per brick. Jeremiah?
How come in this class we really just take notes and we don't really do much work?
Because that's kind of how math is. You got to learn it and then apply it.
And
So-
in 6th grade we would learn a little bit and then do a lot of work.
Oh, and I have less time. A lot of elementaries give an hour or 75 minutes.
Yeah.
So I'm trying to get to the point where you would actually like learn the lesson at home and then come here and do the practice work, which is a flipped model. We just haven't been able to get quite to that point yet. And I still don't completely trust that people would do it because a lot of you aren't doing your homework when it's assigned. You're waiting multiple days. So if I assign you the lesson and it needs to be done for what we're going to do in class the next day, and 5 of you don't do it, we can't really do what we need to do in class the next day. So we need to get to the point where I can trust that you guys are going to do that work. So if we're going to reason through this situation, and you'll see problems like this on your homework, do I know the unit rate right now? Like in that problem above, it was really easy. I could see that one brick was 20 centimeters pretty darn quickly. Let's assume here that every book has an identical weight. They're all like the History Alive books. So they're all a stack of the same books. Even though they look different, let's assume they're all the same. Let's just figure out what it is that we know. How many books do we have? Sean? 9. If I count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9 books. My problem also says that. And Flynn, what's the weight here of these 9 books? So I need you focusing more on what we're doing and less on your water bottle. Okay? Jeremiah?
15.75 pounds.
Right here, 15.75 pounds. So the question I'm asked is, what would the weight of 11 books be? What do I need to figure out first to be able to get to that point? Elena? I want to know the weight per, and weight we can abbreviate WT as long as you can remember, weight per one book, because then what can I do with that value? If I figure out the weight per one book, Anish, I could then just multiply it by 11. Yeah.
Multiplying it by 11, only 9 books. Yeah, but you want to find
Oh,
weight.
The question is, what would 11 books weigh? So, first thing I'm going to solve is what's in red here, the weight of one book. Well, if I want the weight per book, what math do I set up for that? Ellie?
You have to divide 15.75 by 9.
So I'm going to do 15.75 divided by the 9 books, which that gives me, what's my weight per book? Anybody? Just give it to me. 1.75. Ah, thank you very much. If you just want to set those in the middle of the room, you can. Then that, because I need to solve for 11 books, you multiply by 11, and what do we get? And 19.25. Yep, you gotta label that final answer. LBS. So now, you decide to get a job. Good for you. You need some money for the upcoming holidays. You're going to buy your family some gifts. So you're working at Foot Locker. They have a display when you walk in that you can see right here. Each shoebox is the same height, and the height of the display depends on the number of shoeboxes. Well, duh, the more shoeboxes, the taller it is. The less shoeboxes, the shorter it is. They ask you, can you make a display of 12 boxes? Now they look at you and they say, no, really, I want to know, can you make a display of 12 boxes? Are you tall enough? So we need to figure out when I put that 12th box on the top, what's going to be the height of my display? How tall will that stack be? So I want you guys to solve it on your own. You can work with partners close by you. Stick up a hand if you need help. The width doesn't matter. We only care about how tall it is. They want to know, can you reach it? Can you reach the top of the tower, or do they need to get a taller associate? You know how tall you are. Hopefully you know how tall you are.
I don't know how tall I am. I know how tall I am. I'm 5'9".
So, hold up. The first thing you also have to answer is what is the constant of proportionality, which I forgot to notate. Up here, I would like you in your notes. I forgot to write it, but I would like you. This 1.75, that's our constant of proportionality because our unit rate is our constant of proportionality. So, the first thing we're going to solve here is our constant of proportionality. Well, 12 feet every inch, or 12 inches every foot. You talking about me specifically? So, easiest thing to talk about is do your feet first, then add your inches on. So I'm 6 feet and 2 inches. So do your 6 feet. So 6 times 12 makes 72. Then 2 more inches, I'm about 74 inches. Now my wife is about a foot shorter than me. So that'd be a different problem for her. Acadia, how do we find our constant of proportionality here? Hey guys.
45 divided by 4. Which is 11.25.
Now divided by 4. How many boxes are here? 5. So this gives me 9 inches per box. Now wait, I have a question. Could I find a constant of proportionality doing the division the other way around? What if I did 5 divided by 45 and I got an answer of 1/9 box per inch? So that would tell you that you need a 1/9 of a box for every inch in height. Would this still be a unit rate and a constant of proportionality? Yes, but it flips around the input and the output. So then my input would be like, how many inches do I want, or how many boxes? If I plug in how many boxes, I can just say 1/9 times how many boxes will equal my output of inches. Or I could start by saying how many inches I want and then figure out how many boxes I have to plug in. But this is really kind of...
a lot more work than you.
I don't like using the word dumb, but this would be a dumb method. Don't use the fraction 1/9 if you can avoid it. And why do you care how many boxes equals 1 inch? That doesn't really make any sense. We want to know how tall each box is because we know my input of boxes. Yeah.
Why do you have to divide it by 5?
Because we wanted first to know how many inches each box was. Because we want to solve for 12. Now I'm going to show you another method that we could use to solve this. We don't necessarily have to use this method, but it's easiest. Because this 9 inches per box, that is my constant of proportionality. That 9 inches per box. So then, to solve your problem, all we have to do, and I'm going to intro like what we're going to tomorrow, is use the formula y equals mx times x. Now, what this is really telling you is the output you're looking for is going to be some multiplier times whatever input we have. Now, my multiplier that we have here is 9 inches per box, because however many boxes I have to multiply that by 9. So, I set up really that my y is a final height of the display. My multiplier is 9 inches, and my x is my number of boxes, which is here, going to be 12.
So y equals mx is
So, we're going to talk about this tomorrow. I just want this to be in your head, just so you kind of think about it. You don't have to totally understand it, but this is where we're headed to tomorrow. Tomorrow's lesson will cover proportional relationships in equations. We're dealing just with constant of proportionality right now. But the reason that we're doing constant of proportionality is to use it in the equation. Because some people are like, well, why do we even care about this? It makes your life easier. That's my goal here, is to make your life easier. So we do 9 times 12. We can break this up. 9 times 10, 90. I want you guys to be good at breaking up multiplication. 9 times 2. Now add these together. We get 108 inches. So who has an argument for whether or not you can reach the top, and you better support with good details? Sean, we haven't talked really much yet today.
Of how, if you could.
If you could or could not.
Well, you sort of really tall, but then you also have to come and count it with your hands of how
Ah.
tall or how far you can reach.
It's not just your height. It's how tall can you reach. Can you reach higher than your height?
Yeah.
So here's the thing. Here's a really cool thing. Your arm span
Is that tall?
from tip to tip should be about your height. Your wingspan is literally what they call it. From the longest fingers to the longest finger should be about your height. If you have somebody measure this and compare it to your height. So you know your arm is close to a little bit under half of your height. So if I went up to about here on me, that'd be at least 5 feet, plus another approximately 3 feet. I can reach about 8 feet high, but 8 feet is like 96 inches, 108 inches. So what would we infer here? We either need to call in Shaq or we need a ladder. We need a
You
ladder.
can reach that height. You just a ladder.
So our final answer here. Now, I got another way we can do this. Because Jeremiah asked a very poignant question of why, like on topic, why do we have to do that division? The 45 divided by 5. We don't have to solve the question that they're answering of what would be the height of 12 boxes. We have to do the division to solve the constant of proportionality, because the constant of proportionality is your unit rate. But if all I'm trying to do is solve the height of 12 boxes, I don't need to. Because here's what I can do. Do you know what I'm about to set up? I'm going to use this right here. I'm finally going to use cross multiplication. Do you know where I'm going, or can I show this and then take your question? If I know height for number of boxes, or number of boxes over height, I can set this up whichever way I want. I know I have 45 inches if I have 5 boxes. As long as I put height on top and height on top and boxes on bottom, like I set this up, I need height on top, which I don't know, over boxes on bottom. Because this relationship has to be proportional, each shoebox is the same height, that tells you it's proportional. We can just solve this like any old proportion, like where 1/2 equals 2/4, that nice thing. But this gets a little tough right here. How do I go from 5 to 12? I have to multiply by 2 point something. It's kind of messy. So, all of you who keep trying to cross multiply, here is where we finally do that. We take our one set of cross products. Those will be equal to my other set of cross products. So, sorry, did somebody already solve 45 times 12? 540. the one set of cross products will be equal to the other set of cross products. And I'm going to actually make my question mark H. Don't drag out. But then, to solve for H by itself, I need to get rid of this 5. Ellie?
Divide by 5.
Divide by 5 on both sides. And your height equals 108 inches.
Sweet.
Now here's the problem. We still don't know what each box, what the height of each box is. But if the only thing we were trying to solve was the height of 12 boxes, we can just use a proportion. Andrew?
This is just crazy. Couldn't you just do, since we already know that 45 fists is 9, can't we just do 9 times 12 and just get the answer that
So
way?
the other way we can deal with a proportion, I love that you guys are always thinking about these things. We can deal with this by saying, how does the height compare? How does the height compare with the number of boxes? How does the height compare with the number of boxes? That will have to be the same. Because this is proportional, that has to be true. So these blue arrows have to be true, or, well, and
Excuse the interruption.
these green
Can I
arrows have to
all
be true.
choir students to the front lobby. Thank you.
If you are choir and you need to finish your test, that's going to have to be AOR extensions, because we're going to wrap up this lesson real quick and then take time to finish tests. Good luck. Have a good dress rehearsal. I'm going to try to be at the concert tonight, so if I'm moving around to get pictures, ignore me. Jeremiah?
How do you know each box is 5? Because there's
Each box is 9.
but there's 15 boxes.
But there is only 5
Then
tall.
we're trying to do height.
All we care about is height. So the fact that there's 3 columns doesn't matter. All they're talking about is height. So, Jeremiah, do these boxes here or here affect the height of this stack? No. So these boxes here don't matter at all. They're there to distract you. So, on a standardized test, the trick they're trying to play on you is they know that you're going to set up height over number of boxes to figure out the height for each box. But the height of 45 only relates to 5 boxes. So if you set up 45 over 15, you're doing the wrong math. Does that make sense? The height we care about only relates to the 5 boxes. So, try this on your own. Same setup. You have a recipe that calls for 2 cups of flour to make 3 dozen cookies. Hey, by the way, some of us are better at this than others. 3 dozen? How many is 3 dozen? 36. Because there's 12 per dozen. Your friend has a cookie recipe that calls for 3 cups of flour to make 60 cookies. Are your constants of proportionality the same? So the real question is, are your recipes the same? If your constants of proportionality are different, then your recipes are different.
Evelyn DeCarlo to the office, please. Evelyn DeCarlo.
And you guys are like, who?
Oh.
That's why I love when you guys have nicknames and they call you by your real name.
Yeah. I was just looking around for her.
I didn't even know her real name was Evelyn.
It's hard to look at the step by step.
All right, Andrew, to find out your constant of proportionality, what'd you do? Yep.
I'll go.
Yeah, Dom.
Okay. Well,
By the way, your pumpkin looked great. She friended me. I'm so jealous of your weekend. Dom's mom posted pictures of them like camping and carving pumpkins. I'm like, I want to go camping. Dude, I'm so jealous. All right, so pumpkin extraordinaire, how do you figure out your constant of proportionality for your recipe?
So, for your recipe, I did 36 divided by 2 because 3 doesn't is equivalent to 36.
So if we do 36 divided by 2 and we get 18, what's my label on that?
That makes 1 cup is 18 cookies.
Yeah, so this is 18 cookies per cup. So then your friend's recipe that makes 60 cookies with 3 cups, that tells me since I have cookies per cup, I have to set this up the same way. So I have to set up cookies per cup, which comes out to be what? 20 cookies per cup. Are these the same recipe?
No, yours
No.
This recipe is for hers.
That means you're a
cookies per cup of flour.
Now, here's the thing. That's not a very big difference. Your cookies might come out tasting very similar, but you would still not want to mix recipes, because if the recipes aren't the same, don't mix them. That's asking for things to turn out really bad. So, you would want to somewhere notate that these are not the same. These are not the same recipe. We had 2 different constants of proportionality.
Or you could just go to Kroger and buy a ton of
Now, again, could I have set this up the other way around, doing cups per cookie? Yes. My other one would have to be set up the other way around, cups per cookie. What would I have gotten here if I did cups per cookie?
2 divided by 36.
118.
1/18. What would I have gotten here?
120.
1/20th. Remember, it's just the reciprocal. When I turn the order around, it's just the reciprocal. Does this make sense, guys?
Yeah.
Can we
This
do
is
this?
actually
Can we apply this?
Yes.
Can we just do our practice work?
Yes.
Because then we can take questions if there's a question. But especially since we lost our choir kids. All right, just to do this on a table. One more. Let's just do this on table, then graph, then we'll do practice work. So real quick, how do we find the constant of proportionality on the table for our pump rate? Which constant of proportionality is easier to talk about? Would gallons per second or seconds per gallon? Monica?
Gallons per second.
Now, why do you say gallons per second?
Well, I said that because usually you talk about gallons, the amount per time.
Yeah,
But here I'm thinking it actually might be easier if you did it the other way around.
so now you're talking yourself out of your original answer. If I do gallons per second, I get 17 divided by 136. We a lot of times deal with time seconds. But in this situation, it's probably going to be easier to flip it around and do seconds per gallon. So if we do seconds per gallon for all of these, that's going to be 136 divided by 17. 8. Check it all the way through your table to make sure this is a proportional table. 96 divided by 12, does that come out to be 8?
Yes.
Yeah. If I do 84 divided by 10.5
Yes.
All of them are.
and 74 divided by 9.25,
Yes.
Why couldn't it be 7, 7, 7, 7?
so then all of these would have the label of seconds per gallon. So it takes 8 seconds to pump 1 gallon. And actually, if you go to the gas station and watch it's probably faster than that. Gas pumps are really fast. But you can watch it. It ticks up by the hundredths. So if you just squeeze it, let it go. Sometimes, honestly, ask your parents, can I pump the gas if you never have? It's kind of fun because you can, all the math that's actually happening on the screen. Because it tells you how much you've pumped, how much it costs, what the unit rate per gallon. There's so much math going on just the gas pump.
I watched.
You
I did
interpret
watch it.
math as everything.
If I have a chance to upload these, I'll maybe show them to you tomorrow. I'll probably show them to you tomorrow. I've started my Discovery Day project.
What's everybody's project?
So, because my original project idea was going to be to shadow a school that my friend just opened, but they're going to be on fall break during Discovery Day. So, I'm doing all the math involved in renovating a bathroom.
Wait, we have fall break?
No, they do. So this is why you should be listening. You do have a fall break day. It's Friday. It's the compensation for conferences.
When's Thanksgiving?
Jeremiah.
What?
What was I gonna say? Oh, I was gonna say, once I was little, when I was like 6 years old, and we were driving back from Dayton, and then I had to pump the gas, and then I spilled it all over my pajamas.
Yeah. Yes. Some people think it smells good. Some people don't like the smell. Now, hold up. Last thing that you're going to need to be able to do on your homework, I think there's like 2 questions like this. How do I find the constant of proportionality when it's on a table? Monisa?
You just find for one.
Which one?
On the x-axis.
Yeah. On your paper. Thanksgiving doesn't matter right now. On your paper, we need to put find x equals 1. That is your constant of proportionality. So, right here, you can notate it on your table. Where x goes to 1, whatever the y is, that's your constant of proportionality. So here my CP is 80, and what the point 180 represents, so we need to give it a label, 80 beats per second. And that's actually wing beats. Their heart rate is way faster. Well, no, sorry. If that was beats per minute, that'd be slow for a heart rate, but that's beats per second. This is why a hummingbird's wings move too fast for us to see. Your eyes cannot see. Now, if we film it, we can slow-mo it, and we can watch it in slow-mo. But even once you slow-mo, it's hard to see the wings because they move so fast.
We have time, right?
So, we have time. If you need to finish your mastery or you want to check your mastery, please come up and grab that. Otherwise, grab a Chromebook, and I got to get the homework up, but then you can work on the homework.